Now moving on to the next segment, that is the parietal lobe. Parietal lobe, it consists of all the areas. Again, I will refer to the lecture on the gross anatomy of cerebral cortex. All the areas behind the central lobe, the central sulcus, and in front of the parieto-occipital sulcus. You cannot see very much clearly the parieto-occipital sulcus from this. We will see here the primary area, the association area, and then within the association area there are angular and supramarginal gyruses. We will see them one by one. So, primary somaesthetic area S1, this is the Broadmann area of 3, 1 and 2, that is consisting of the post central gyrus, and if you go on post central gyrus all the way from above the lateral sulcus, and if you go on to the medial aspect you will see it right here, the posterior aspect of the paracentral lobule. So it is a sensory cortex, so it will have prominent layer numbers 2 and 4, that are the granular layers, and in those layers there are layer of bilarger, that in the layer 4 there is outer layer of bilarger, so that is very prominent, and this sends signals to the relay centers and feedback and modality. So if primary motor area could have been thought of as a large switchboard at a large keyboard, this is can be considered as a large signal board, large light board. So each of the point represents a particular point of the body. The signal from each of the point of the body is received at a particular point on this primary motor cortex, on the primary sensory cortex. So if we map each point against the area that it is supplying, that map is called sensory homunculus. It is, and again, an inverted human, and most lateral aspect there will be head and neck, on the and on the most medial aspect there will be lower limb, lower trunk and genitalia, and it majorly receives signals from the contralateral aspect, especially below the neck, and from head and neck it majorly receives bilateral signals. So some from the same side, majorly from the contralateral aspect. And here you can see the homunculus is again asymmetrical. The area is so much given to the head and lips and hand as compared to the legs. Here the area size is proportional to the sensitivity of that area, the number of receptors present in that area. So what are the most sensitive parts of your body? Your fingers, your tip of the fingers, your tip of your thumb, your lips, your tip of tongue, your genitalia. So all these structures will have a bigger and greater representation as compared to the rest of the body. So you can see the sensory homunculus does not match exactly to the motor homunculus, because the proportionality higher area were given to those areas of the body who had fine control, and in sensory homunculus the larger area was given to those structures which had more sensitive. So any lesion will lead to the contralateral sensory disturbances, and most importantly the distal aspects, and the crude touch, crude tactile, thermal, these sensations will return because they are appreciated at the level of thalamus too. But even the thermal being judged, he still cannot assess the degrees of warmth. Tactile sensation, he will know he has touched someone, but he will be unable to give the details. What is the texture of it? What is the location of it? What is the weight of it? So all of these functions will be lost, and due to the different reflexes going through it, the muscle tone will also be lost. If you remember, this area was also sending downward signals with the corticospinal tracts, one third of the fibers in fact. Then there is secondary somaesthetic area and association area. Secondary somaesthetic area is somewhere here on the upper aspect of the lateral fissure, lateral sulcus, and it has homunculus. It has homunculus. The head is represented anteriorly and the leg is represented posteriorly, and its significance is not that much understood. But this area, I would like to go into a little detail. This is the association area, somatic association area, almost for a rest of the parietal lobule that is left. So that will be included. That will include Broadmann area 7, 5, 40, 39. So all of these areas are included in the somatic association areas. So it receives its signals from the primary sensory area, the primary somatic area, even from the visual association cortex. And this is the point where the sensations received in the primary area are translated into something meaningful. You compare the signals coming from the primary area and you may compare it with the memory you already have and you make a judgment. For example, if I close my eyes and place my hand in interior aspect, I can recognize that in front of my is my keyboard. So the signals that were received in the primary area, and there must be some time in my past where I first felt that and someone told me that this is a keyboard. So it compared it related it to that memory and helped me recognize it. So if I look at my bottle, I'll just place my hand right here, and if I do not even look at it, I can recognize that it is my flask. So this particular shape, this particular texture means that it is my flask. So that is the function of this somatostatic association cortex. And this ability to recognize objects by touch, that is stereognosis. And the lesion will lead to astereognosis. That means the person will not be able to recognize objects by touch. You can just put your hand in your pocket, pull out the pen or razor or handkerchief or keys, whatever you have in your pocket. So you are constantly using stereognosis if that is person not able to do. There is not loss of sensation. The person is still feeling that he can something describe somewhat too, not completely, but this integration of somatosensory and visual things to recognize an object, that is lost. There is a statognosis, that is a variant of it in which a person is unable to recognize position of the body part. If you would ask a person to close the eyes and you passively put his limb up, he will say, yes, my right arm is put up. So that is ability of statognosis. That position of that will not be able to be done if there is a lesion of it. Then there is apraxia. Apraxia was the loss of skilled movements, loss of learned movements, disruption of patterning and execution of learned movement. That is the thing that we discussed in the premotor area, but somatosensory association area damage also leads to it. You see, whenever you are doing any complex activity, when you are executing a stepwise plan, then the association area, the sensory areas are continuously monitoring each step. Now this is done, now we have to do this. Now these two things are done, now we have to do these four things, and so on. So if these sensory areas are lost, again the skilled movement function is also lost. Asomatognosia, and these are very similar terms. This is asomatognosia, this was astereognosis, this was astatognosia. What is asomatognosia? If the non-dominant hemisphere is damaged, the same areas on the non-dominant hemisphere, by the way, this all holds true when dominant hemisphere is damaged, more true when dominant hemisphere is damaged. If non-dominant hemisphere is damaged, that is the right hemisphere in most cases, that leads to the person becoming totally unaware and neglectful of the contralateral half of the body. So it will be the left half of the body. The person will totally ignore it. When dressing him, he will not put on the coat on the left side. He will not undress on the left side. He will shave on the right side and leave on the rest. Wash the right side, leave the rest. He will behave like the left side of the body don't exist and you don't even know what's happening. And even if you try to ask a person to draw a clock, he will very cleanly focus on the right side and the left side will be neglected. And if you try to make the clock, and he will make up so that all the things will end by the right side, and he will totally forget that there is something on the left side too. There is no visual defect, but he's denying, he's failing to accept the presence of those things on that aspect. So that is asomatognosia.